Hello guys, today we are starting 4-7 similar figures. So we're going to go through and fill out some information for this first. Okay, similar figures have the same shape, but a different size. Figures are similar if they're corresponding, which means corresponding is the same location. Corresponding angles are congruent. And remember this little wavy line with the equals underneath means congruent. I will use that for shorthand. And for angles, I will use an angle with an S behind it. And then we also have that corresponding sides are proportional, which means it can be set up as a proportion. Proportional. All right, the fraction of corresponding sides is called the scale factor, which we talked about in our last section some as well. Okay, so when we're looking at this, we first have to learn to determine if a triangle or a shape is similar. So we're going to use these two triangles here to determine how to verify that. Okay, are the triangles similar? Well, we have to see if the corresponding angles, that means they have at the same location, are congruent. The way we see that is here, if I look at the arcs, okay, angle A is in the same location as angle D, and they have the same, just one arc, so therefore they are considered to be congruent. So we would say angle, it says give the corresponding angles and their relationship. When it says their relationship, it's talking about if they're congruent or not. So angle A is congruent to angle D. And then I'm going to look at B. It's got a double arc. B is in the same location as E. So therefore, and they both have arcs, double arcs. So therefore, we say angle B is congruent to angle E. And then we look at the last one, which is angle C and F. They are in the same location and they both have triple arcs. So angle C is congruent to angle F. Okay, now we're talking about the corresponding sides and their relationship. That means which sides go together. Okay, since all three of these angles, sets of angles are congruent, then this is a similar triangle. So the answer for number one is yes. Okay, and way we can prove that is by the angles, but then also if I look at this, if I do 4 times 2, that gives me 8. If I do 5 times 2, I get 10. If I do 7 times 2, it gives me 14. And these are the sides that are corresponding. So if I say AB over DE, guys, sorry for that slight pause. Okay, so the corresponding sides, AB goes with DE because they are in the same location, which is going to be 4 over 8. Then we have BC goes with EF, which is 5 over 10. if you take the measurements into K. And then we have AC goes with DF, or you could think of it as CA goes with FD, which is 7/14. And these could be flip-flopped, okay? All right, so here we go. What is the scale factor? Okay, we don't have one labeled as new or old here, which is the way we kind of thought about our model to actual when we talked about scale factor before. So it is determined by the way it is read. So it says triangle ABC. So this is going to be the first, or this is going to be our new or the model. And then triangle DEF is the second one, or it's going to be the old or actual. Because remember, scale factor is always the new over the old or model over actual, whichever way you would like to think about it. Okay, so I'm going to be doing triangle ABC to triangle DEF. So I pick one side. It doesn't matter what side, but it's going to be the corresponding. So what I'm going to do is I'm going to pick the 4, which means that I'm also going to pick the 8. The 4 goes on top, so this is 4/8. I always simplify, okay? So you must simplify, which this simplifies down to 1/2. So the scale factor is 1/2. Now, for number 5, it's asking what is the scale factor, and then it flip-flops. Okay, so you can do that one. Now, moving on to writing the similarity statement. A valid similarity statement must match corresponding angles and sides. Match the corresponding angles and sides. Write a similarity statement for the triangles above. Oh, and remember, the symbol for similar is just the curvy line. It's not the congruent with the equals underneath. It's just the curvy line. So I'm going to kind of write it in the order of the angles and the way they correspond. So we have triangle ABC. So I went ABC. So that means I do the symbol for similar, the wavy line, triangle, and then I go in the same order, DEF. DEF. All right, so now if we're finding measures, because the sides of similar figures are proportional, you can use a proportion to find a missing side length. You simply match up 2 pairs of corresponding sides, okay? And remember, it has to be corresponding sides. All right, here we go. So we're going to flip over and we're going to look at number 7. And there's a reason why I skipped 6, because that's straightforward. So for number 7, you'll notice that there are different orientations. The right angle is in a different spot. You have a choice. You can either leave it as it is and use the arcs and the right angle symbol to match things up, or you can redraw the triangle, okay, to where it looks exactly like this one. There's going to be my right angle, okay, which means here's going to be the arc and here's going to be the double angle. So therefore, with that being said, the side between the right angle and the double angle is double arc is set 6. The right angle and the single arc is 11.25. And then we have the diagonal, which is 12.75. You don't have to redraw. It is helpful for some. Okay, now we know my directions say to find X. So I know that one set or half of my proportion has to be the missing side, the X side, and the side that goes with it. these two. So there's half my proportion. So I'm going to have x over 11.25. That's just the way I wrote it. I could put 11.25 over x. It's just whatever's on top on one side has to stay on top on the other side. Now I just pick a side to use. It doesn't matter which side, but they have to be corresponding. The less decimals I got to use, the less I'm going to use. Okay, so when I look at this, so I'm going to use the 6 and the 8. Now, I've got to remember I put x on top. So that means the 8 has to be on top. So we have 8 over 6. And now I have my proportion written, so I can solve. We multiply diagonally. And I get 6x equals 90. Divide by 6, divide by 6. X equals 15. Okay, one more. Looking at number 11. Okay, so for number 11, it's very nice in the fact that it's telling me that these are similar. So it's given that triangle PQR and SQT are similar. We want to find ST. Okay, find ST. That means this is where my X goes. Okay, one thing that might be helpful here is that, so it says PQR is similar to SQT. Okay, so therefore the big one is similar to the small one. What might be helpful is take this small one out and make it a separate triangle. So we have STQ. And I know that this is 25.6. This is my X. Okay, what I have to realize is it's giving me the dimension from here to here is the 38.4. So I have to add these two together to get a total of 64 for from here, from all the way from P to Q. Now I've got information, okay? These two sides go together, so I'm going to have X over 48 equals, I started with the X on top, so I'm going to have the 25.6 over 64. And now we solve. So we multiply diagonally. And I end up with 64x equals 1228.8. We divide by 64. And x equals 19.2. There's no units, so I don't have to write them at this point. There we go. This is the notes. You will finish the notes page and finish the homework assignment. Have a great day.